Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. As you'll learn with regards to IT security, cybersecurity, information security, or whichever term is trending, there's a foundation called the CIA triad, which stands for confidentiality, integrity, and availability. This impacts all systems and data within the organization or that the organization uses. That also means that any control or mechanism that we put into place is going to impact one of these components. Confidentiality is the idea that only authorized people can access, see, read, or interact with systems and data. Unauthorized people either can't see, use, or make sense of the systems and data. Access permissions and encryption are common controls to use to protect confidentiality. The goal of integrity is to prevent unauthorized changes or modifications to data, either while it's sitting on a computer's hard drive or if that data is being transmitted to another system. Imagine if an employee can modify their sales commission figures in the system and get paid more. Common controls include a variety of checks, hashing, data checksums, and other comparisons with computed data values. By maintaining availability, you're ensuring that systems and data are accessible for authorized users when they need them. Ways of ensuring availability include system redundancy, data backups, and business continuity. As you might already be thinking, security can impact availability, and you're right in that it's a trade-off between security and ease of use. I also want to point out that in organizations, you might see a conflict between IT departments who are measured on the availability of systems and security departments or teams who are focused on balancing the entire CIA triad. One of the hot topics of discussion over the last several years with regards to network architecture is around trust. Traditionally, once you were connected to a network on the inside, you were considered trusted. This has obviously led to a lot of issues with data breaches and other security concerns. Zero trust is the idea that nothing is implicitly granted trust and that it has to continuously be evaluated. This idea also works under the assumption that the network has already been breached and helps minimize the impact. I highly encourage you to do some more research into zero trust and review the NIST special publication 800-207 Zero Trust Architecture. Defense in depth is a philosophy that you can't build a completely secure perimeter on your network, and so you should assume that defenses can be beaten. This idea has been around for a while, but it includes controls like strong physical security, network segmentation, separation of duties, and strong password policies. You might even see defense in depth strategies requiring the use of multiple equipment vendors to prevent mass exposure to a single vulnerability. Separation of duties is another important strategy that splits up access permissions so that a task or business process can't be completed by a single person. This is really focused on managing the risk for two key types of situations. The first one is employees who might abuse or misuse systems. For example, you won't see the same person configuring systems and then auditing those same systems. The second situation is limiting impact of account compromise. If a single account can't perform a critical business function, then attackers will have a more challenging time trying to compromise multiple accounts compared to needing a single set of account credentials. When it comes to protecting our networks, we need to be aware of any possible threat. Network-based threats are any form of potential attack against a network. These threats can be external threats like hackers on the internet, but they can also be insider threats like disgruntled employees. For a threat to be successful, they need a vulnerability or a weakness that they can then take advantage of, which means to exploit a vulnerability. Typically, we think of vulnerabilities in software and technologies, but as you progress in your career, you'll see that non-technical areas like policies can also have vulnerabilities. Mitigating or fixing a vulnerability can be as easy as updating software or removing certain technologies. If we can remove the vulnerability or minimize the probability of the threat being able to exploit that vulnerability, then we've reduced the risk to our organization. If you want to know more about how vulnerabilities are tracked and scored in the industry, I recommend that you check out the Common Vulnerabilities and Exposure, or the CVE database, which is hosted by the MITRE Corporation. For the rest of this section, we're going to discuss common network threats that you need to be aware of. Spoofing means to pretend to be someone or something that you aren't by placing false information into packets. Common things that can be spoofed include source MAC address, MAC spoofing, and source IP address, IP spoofing, which can make it look like traffic came from somewhere else, address resolution messages, or ARP spoofing to attach an attacker's MAC address with a legitimate system. DNS poisoning is similar to where the DNS server's cache points to an evil web server or system instead of the correct one, although this can be actually prevented with domain name system security extensions or DNSSEC. Email addresses to hide the real source email address, web addresses so it looks like you're on a legitimate website but you aren't, and usernames to make it look like somebody specific is contacting you. One of the challenges that exists within technology is that attackers frequently try to abuse protocols, which means using a protocol for some other purpose than it was created for. A popular example in the hacker community is to use the SSH protocol to send other types of traffic over the network, and since SSH is encrypted, the entire session is then encrypted. Attackers will also use malformed packets, which are packets with data or data structures that aren't expected that might lead to crashing the system, corrupting data, or even giving remote access. Scapy is a popular tool to do this with. No matter how good software or technologies are developed, over time there's always some vulnerability that's discovered or becomes possible to exploit due to advancements. Zero-day vulnerabilities or zero-day attacks use these unreported vulnerabilities to exploit systems or cause damage. Following security best practices is really the only way that you can minimize the impact of a zero-day because, again, they're unknown issues that the vendor has to fix. Typically, zero-day vulnerabilities are kept a secret as long as possible because they take a while to discover, and then the attacker can't use them anymore once the vendor fixes the issue. Security researchers are also trying to find these constantly and then responsibly disclose them to the vendor, which usually results in a financial reward in a bug bounty program. If attackers can successfully trick systems into thinking that their rogue system or device is a trusted device, then they can do a lot of damage. Typically, devices like routers, switches, firewalls, and DHCP servers require a lot of trust in the network. So what can we do? Well, one thing that we can do is DHCP snooping, which is a feature that tries to sniff out rogue DHCP servers. It does this by creating a DHCP snooping binding database of MAC addresses for all the network's known DHCP servers that are connected to trusted ports and clients that are connected to untrusted ports. Then if DHCP server messages start coming from an untrusted port, alarms can be sent to administrators, and those ports can even be blocked. RAGuard, RAGuard, or Router Advertisement Guard is specifically for IPv6 networks, and it enables a switch to block router advertisements and router redirect messages that aren't sent from trusted ports or that don't match a policy. ARP cache poisoning attacks target ARP caches on hosts and MAC address tables on switches. If you remember back to what ARP is, it deals with resolving IP addresses to MAC addresses, and every system stores a local ARP cache list of known IP addresses and their known MAC addresses. On Windows systems, you can open up a command prompt window and use the command ARP-A and see this information. Unfortunately, there's no security with ARP, and any device can announce its MAC address without receiving a request. That means an attacker could have their system claimed to be a router or some other device fairly easily. The danger of this is that once an attacker poisons the cache, they can insert themselves in the middle of communications between you and another system, which is called a man-in-the-middle attack, and listen or eavesdrop on all that traffic. A technology that helps defend against ARP cache poisoning is Dynamic ARP Inspection, or DAI. Dynamic ARP Inspection is a technology in switches that relies on ARP information collected by DHCP snooping in the DHCP snooping binding database, which provides a list of known good IP and MAC addresses. DAI can detect the bad addresses that don't match the database and block them. DAI and DHCP snooping both require something called switch port protection in order to work. Denial of service attacks target a server or servers by overloading them with requests to either significantly slow down the response time or to completely stop the server or the service. You can have physical denial of service attacks by physically shutting down a system, but usually the most common form that we see is flooding a server with tons of traffic from a system so that the server either stops responding or it crashes. Depending on the server, you might not be able to send it enough traffic with a single computer. Distributed denial of service or DDoS attacks are where attackers can install malware on various systems or control other computers called zombies or bots that together form a botnet to send a massive amount of traffic and requests to servers. Botnets are controlled through a command and control or C2 system, and the attacker sending the commands is usually referred to as a bot herder. Another type of attack for denial of service is called a reflection attack. This is where an attacker sends traffic to a server or system, but the attacker used a victim's IP address as the spoofed return address. This way, all the responses go to the victim. These usually get combined with an amplification attack, where the attacker sends small requests to a server that results in large responses that again are returned to the victim, and if there's enough traffic, the victim's overloaded to a halt, or it's going to crash. Deauthentication attacks, or deauth attacks, are also a form of denial of service attacks, but they target 802.11 Wi-Fi networks. Specifically, they target the deauthentication frame to kick people off a wireless access point connection. DHCP starvation attacks are when an attacker can trick a DHCP server into giving away all of its leases or IP addresses by spoofing packets to the DHCP server, which is also referred to as a DHCP scope exhaustion. Then once all the available addresses are gone, attackers can encourage clients to switch to a rogue DHCP server that the attacker controls. On-path attacks, which are also called man-in-the-middle attacks, are when the attacker can insert themselves in the middle of a conversation between two different systems where they can either read or modify traffic being exchanged. These kind of attacks usually follow an ARP poisoning attack, but since there are other ways of doing this, I want you to focus on the primary definition, with the attacker being in the middle of the communication channel. Zero trust network models and encryption can help in preventing this from happening. Session hijacking is when an attacker tries to intercept a valid computer session to get authentication information. This is like a man-in-the-middle attack, but these attacks are purely focused on getting authentication information. These attacks can even be the result of stealing session cookies to log into a website or a service. VLAN hopping is something that we don't really talk about anymore, but it basically enables an attacker to access another VLAN that they wouldn't normally have access to by abusing VLAN commands on a switch. This convinces the switch to change the switch port connection to a trunk link. In this section, we're going to talk all about password attacks that you need to know. Love them or hate them, passwords are still a very common thing when it comes to authenticating users. Since passwords are so common and at times trivial to crack, they're also a target for attackers. There's two types of password attacks that you need to be aware of: brute force attacks and dictionary attacks. Have you ever wanted to guess a password or combination to something so badly that you just start entering every combination that you can think of? Brute force attacks are exactly that, where an attacker will guess every possible combination. We most commonly associate brute force attacks with attempting to guess passwords, but it can really apply to anything where an attacker is guessing combinations for something. Dictionary attacks use a list of known words and partial words, and then a tool will start guessing passwords by combining words or even substituting characters. Have you ever used a number in place of a letter in your password? Guess what? The tools can do that too when they're guessing. These kinds of attacks are only as good as their dictionaries, so longer passwords and passphrases can make dictionary attacking tools less effective. One of the common misconceptions is that all attackers or malicious people are on the internet or outside of your organization. Unfortunately, people on the inside can also be malicious and want to cause harm too. The big difference is that they're considered somewhat trusted and they might have legitimate access to something. Insider threat is a term that we use to identify malicious employees or trusted contractors who go rogue. Think about it. These are the people that we're supposed to trust, so they're going to have some level of access to the systems or areas of our buildings. This means that they can destroy data or cause immediate damage to our networks and organization. Sometimes we might call trusted employees who make unintentional mistakes as insider threats, but usually the term is reserved for malicious actors that are intentionally doing harmful things. Within an organization, there's two main types of user accounts that exist. We have trusted users who have at least some administrative level privileges or access, and in some environments, you might hear them called privileged users. It's extremely crucial that you understand which permissions that these users have based on access control lists or ACLs of a system. And then we have untrusted users or general users who have no administrative powers. The big idea here is that trusted user accounts or privileged user accounts have elevated rights to do higher privilege activities, and those accounts should have more restrictions in place so that they aren't easy to compromise. Additionally, it's crucial that you apply the principle of least privilege and only give out accounts and the privileges that people need to accomplish their job and nothing more. It's also a best practice to disable or delete any guest accounts that exist in your environments. Malicious users aren't a type of account, but rather a user who consciously attempts to do things that they shouldn't do. These users might sniff packets on the network, use a port scanner like Nmap to see which services are running, or even perform banner grabbing to enumerate a service. Since we're talking about physical and local access to our organization, we need to talk about the system lifecycle. All systems in your organization should have a process where they're tracked and managed from the moment that they come into the company until they're decommissioned and either destroyed or recycled. You shouldn't look in the closet and find a server that you forgot about 10 years ago. As systems reach their end of life, which they all do, they need to be sanitized, meaning that all data is removed, and then they need to leave the organization one way or another. Sanitization procedures vary by device, where some might just need to be wiped clean and others might actually need to be physically destroyed. Either way, there should be an organizational policy that talks about the procedures. Malware is something that everybody's familiar with to some level, but the term describes any program or code that does something that you don't want to happen. Most commonly, people think of viruses when they think of malware, and we'll cover that too, but there's other types of malware that you also need to know about. Crypto malware is a category of malware that uses encryption to lock a user out of a system. Basically, the malware encrypts the hard drive, boot drive, and anything else that it can access. Ransomware is a form of crypto malware, but the main difference is that the ransomware requires the user to pay money, which frequently is in the form of cryptocurrency like Bitcoin, to decrypt or unlock that system. Sometimes we also call this crypto ransomware. One of the main reasons that ransomware uses cryptocurrency is because it's more difficult to attribute the actual activity to a specific individual. Crypto ransomware started to originally surface around 2012, but today its presence is increasing dramatically, and it's still very difficult to prevent or to clean up. CryptoWall and WannaCry are two very well-known variants, but there's more all the time. Viruses are probably the most talked about form of malware, and sometimes it's used as a blanket term for malware by people that are outside of the tech field. Viruses are a type of program that attaches to some host file or application on your system, and when that user launches or runs it, the virus is going to activate and do some action, like erasing a part of the hard drive. Viruses might replicate to other applications or other drives on your system, but not across the network. One of the primary things that a certification exam especially is going to focus on is going to be that viruses need human action for them to spread. Worms are very similar to viruses, except they're really interested in replicating throughout a network. Two other key differences are that worms don't require human action to activate, and they don't need to attach to a host file to start infecting systems. Have you ever heard of macros inside of Microsoft Office applications? A macro itself is built into Microsoft applications like Word and Excel, and they let you automate repetitive tasks. Unfortunately, macros are notorious for being malicious, and they can replicate and activate just like a virus. That's why you'll see these applications asking if you want to allow macros to run, and why many organizations are going to block this capability, at least by default. Imagine if you had a disgruntled employee who was fired, and then all of a sudden the network started crashing. Logic bombs are a form of code that's written to execute certain tasks or functions when conditions are met, and they're typically malicious. In our example, the employee's account was enabled when they were employed, but when they were fired and their account was disabled, the logic bomb triggered. Have you ever heard of the story of the city of Troy and how they used a wooden Trojan horse to sneak troops into the city and take control? The horse wasn't what it seemed. Trojan horses, which are also sometimes just called Trojans, are a piece of malware that look or pretend to do something legitimate, but behind the scenes, they're also doing something malicious. Trojans frequently show up as small applications like games or free screensavers, but in fact, they'll open up ports on a system so that the attacker can connect and capture keystrokes, steal passwords, and several other malicious things. Trojan horses don't replicate themselves, but they could be included in worms or other ways of distribution. Rootkits take advantage of low-level system functions to hide themselves from anti-malware software and to gain privileged access. With low-level access, it's much easier for them to evade software-based security mechanisms. Adware is a program that monitors the types of websites that you frequently visit and uses that information to target you with advertisements, usually in the form of a pop-up window. The people who push this stuff are sneaky in their advertisements to entice you to click, but be careful out there. Spyware is software that sends information about your system or actions to somebody over the internet. The information could include lots of information, like browsing history, applications used, keystrokes, and even email contacts. Spyware can even be included in adware. We can configure all the technology in the world to secure an organization, but we still have to worry about the human element, which can allow attackers to bypass security controls. Social engineering is the process of manipulating people inside of a network so that somebody outside of the network can gain access. Social engineering really focuses on taking advantage of human nature and our habits as people. I'm sure that you're familiar with the telemarketer scammers that call you at home, but have you ever been contacted at work? This is a common technique where an attacker might try to convince you to provide your username and password. You might also see somebody dressed up like a repair person or a cleaning crew that starts snooping around the building. Even though picking up little pieces of information like employee names and job titles might seem harmless, when you combine a lot of this information together, it can lead to a more believable and sophisticated social engineering attack. Phishing is one form of social engineering that you need to know about. Phishing attacks typically come through email, and they pose to be a legitimate business like your bank asking you to verify your credentials. A lot of times the links that are included are to websites that are very close in spelling to the legitimate site, or attachments in emails might have legitimate titles. Think about when you go to the ATM to get money out of your bank. You insert your bank card and then you enter in your PIN. But what if somebody's looking at the keypad over your shoulder and they steal your PIN? That's shoulder surfing in a nutshell, but it doesn't have to just be PIN codes, and it could be some other piece of information. Remember when I mentioned that somebody could dress up like a repair person? Well, protecting physical intrusions is important for both server areas and client areas. For servers, you'll want to have them locked in a secure area or room so that only authorized people can access them. We don't want a hacker in the building to plug directly into one of our switches. For client areas, employees should make sure that no passwords or useful information is left just sitting out on their desk. Additionally, we want to train users to lock their computers when they walk away from them, and we need to implement screensaver locks as a backup control just in case they forget. When it comes to technology, almost everything is going to have some type of vulnerability or weakness that a threat could potentially exploit. It's not necessarily guaranteed that it's going to happen, but there are some common vulnerabilities that you need to know about. Whenever a system is deployed, a lot of services are going to run, and some aren't actually necessary for how that system is going to be used. Basically, services are applications or things being used by applications that are running in the background. And if you're on a Windows system and you press Control-Alt-Delete, you can open up Task Manager and see everything that's running. The problem with running services that you don't actually use is that you're leaving the door open for attackers to exploit them. And if you don't need them, then you'll either want to disable them or remove them completely. You can also open up a terminal window on Linux or a command prompt window on Windows and use the command netstat-n to see which ports that services are using. It's also a good idea that you only allow the ports that you need to get through your firewall and configure blocks for everything else in your access control lists. Systems and applications need to be updated as patches are released by the vendor. It's just that simple. That means operating systems, firmware, or anything else needs to get updated. Sometimes you might have a business need for a legacy system, which is a system that's no longer supported by the vendor or that's running an old operating system. It can be possible to get extended support from the manufacturer in some cases, but that's outside the scope of this discussion. If there's a legitimate reason for either unpatched systems or legacy systems, then you better make sure that it's isolated from the rest of your network, because these can create massive security vulnerabilities in your network. Today, there isn't much reason to not use encrypted channels for communication, like managing devices or even just using HTTPS on websites. Does it happen? It sure does, but using protocols like SSH and VPNs is something you need to do. Just do it. When you log into a system, it most likely requires a username and a password for access. Unfortunately, certain protocols send the username and password in clear text, meaning that somebody watching that traffic can see it all. You should also avoid systems, applications, and coding practices where the credentials are stored in clear text format, again, so anybody that has access can't read them. RF emanation is a security vulnerability that not everybody is going to deal with in their career, but if you weren't aware, radio waves can penetrate through walls and potentially allow attackers to see what's going on in those radio waves. These leaks are called emanations, and the US National Security Agency, the NSA, has a set of standards called Tempest that defines how to shield systems and prevent emanations from leaking out. Typically, these requirements only apply when you're working with government agencies. You may or may not be familiar with the term hardening your network. Basically, what it means to harden a network is to implement security so that you can prevent all the bad things from happening. Let's talk about some of the ways that you can harden your network. Security really starts at the physical level. Think about it. If somebody can just steal your server, then they can probably eventually get what they need. Having proper access controls in place is crucial to protect the physical level. Do your server rooms have locks on them? Do people return their keys to those rooms when they're leaving the company? It might seem simple, but you'd be surprised. A lot of companies use badge readers where you swipe a proximity card up to a sensor to gain access instead of physical locks with keys. In lower tech situations, a cipher lock might be used, which is basically just a physical lock where you can punch in a code. The highest technology companies will use biometrics for authentication, like fingerprint readers or iris scanners. If companies want to get the most benefit from these kind of controls, they'll use multi-factor authentication, meaning at least two factors, like a badge reader, something you have because you need a badge, and a PIN number, something you know. Companies will sometimes have policies saying no tailgating, which means that every person has to physically badge into a room for access. Piggybacking is a similar term where the authorized person is aware of an unauthorized person's attempt. The idea is that you can't hold the door for somebody else. Sometimes you'll see guards to help prevent this, but you might also see a man trap like a turnstile or an actual room that's meant for one person to get access at a time. Many companies are starting to install smart lockers, which are lockers with a code that allows employees to access them. This is just like Amazon delivery lockers or others that you've seen. Maybe your support staff needs to securely deliver a new laptop to a user after hours, so this is an effective way to do so. This is important because in a company, you have to track physical inventory, like assets, such as a computer. When it comes to physical security, you still need video surveillance, and that's not going away. IP cameras and closed-circuit televisions, or CCTVs, are video monitoring systems that are watched by security staff to help identify issues or to investigate further after the fact. Sometimes these systems are going to be triggered by motion detection systems, but they can be extremely useful if they happen to catch some nefarious activity happening in real time, and then the authorities can be called. I'm sure you've seen those videos of people watching their house get robbed on their home video systems, and then they call the authorities. It's the same idea. Now that the physical aspect of our network is secured, we need to talk about securing the actual network. Specifically, we're going to talk about network access control. Accounts in an organization are assigned to an individual user, just like how they have a unique employee ID number. We grant these accounts using the principle of least privilege, meaning that a user's account only has the privileges needed to do their job. We're trying to prevent both unauthorized access so a person doesn't have too many privileges and improper access so that they aren't inadvertently given the wrong privileges. Good practices include disabling unused accounts like former employees and granting permissions to groups that users are then added to instead of giving that individual user permissions. This is important because when a user is added to a group, they will inherit those permissions and then it's easier to track. The point to take away is that if you don't have a good handle on user permissions, your network is going to be like the Wild West where users can do whatever they want. Network access control, or NAC, is an approach where any device connecting to the network must meet certain criteria before it's actually granted access. Keep in mind that there's actually a software from Cisco that's called NAC that will actually perform actions like checking the patch level or making sure that antivirus software is installed as part of the posture assessment of the device. When systems like this perform posture assessments, they'll use one of three flavors of agents, which are a process or program that's running on the connecting system. The first type is persistent agents, which are installed on the computer and they run every time it's booted up. Then we have non-persistent agents, which are small pieces of software that are ran to perform checks on that system, and once they disconnect, the agent will be released from memory and wiped away. And then we have agentless. Agentless posture assessments were developed out of a need for a flexible solution, but the checks that they can perform are not anywhere near as extensive. Regardless of which option that you use, if systems pass the checks, then they can access the network. Devices can also be denied access, or it's possible to quarantine the systems with limited access until they can actually pass the checks. For example, if they need to download the latest antivirus updates. Separating or segmenting areas of your network with VLANs, access control lists, firewalls, and other measures that you can take is extremely important for securing your network. Some systems will be riskier than others. Some systems will be more important to the business than others. It's just how it is. Network segmentation enforcement allows you to block or allow traffic to enforce your segmentation policy, and this happens at the boundary between different segments of your network. Microsegmentation allows you to take it a step further and do segmentation enforcement at the host itself or at the switch that it connects to, and is important for zero trust networking where every action and system is constantly verified. When we think about securing networks, we also have to think about the actual devices like network gear that are on our network. Some common considerations include changing default credentials. Many devices come with default credentials from a manufacturer like a username and a password. It's not hard to locate these defaults, and it can be done with a simple Google search. Whatever you change these to, make sure that you use best practices for passwords, like long, complex passphrases. Keep devices up to date. Whether we're talking about a server, client, or networking equipment, they all have software that occasionally needs to get updated to fix vulnerabilities. Disable unnecessary services and ports. Any service or port that isn't required needs to be disabled. Make sure that anything enabled out of the box is absolutely necessary. Only use secure protocols. When services or protocols are required, make sure that they're the most secure version possible. For example, avoid Telnet and use SSH to remotely administer a device. And implement quality of service or QoS filters. Control plane policing is a great example of a feature on Cisco devices that helps to manage the flow of control plane packets to avoid a denial of service attack situation on your switches. Host devices or systems, like the ones that your end users log into, are where a lot of traffic starts and ends, which means it's the last layer that you have to protect. Regarding malware prevention, anti-malware software is one of those controls that most people are familiar with because it's also on their computers at home. Ideally, this software can stop any malware from infecting computers, but of course, it's only as good as its latest updates, which are also called definitions or signatures. Basically, these are just a list of known malware for the tool to look for. There's a few different deployment methods for malware prevention that we need to talk about. The first is host-based, which is a traditional method with the software installed on the local client system. This isn't as useful when you get a lot of client systems. We have network-based, where you have a server centrally controlling the operations and usually a small client installed directly onto the systems. And then we have cloud or server-based, where servers store the software on a remote location, either in the cloud or on a server, and it's up to the host system to access the software and run it. Okay, so what are indicators of malware? Well, have you ever seen a computer that seems to run really slow? Maybe the system randomly crashes. Maybe there's just unusual things that are happening. It's completely possible that that system is infected with malware. So how can you identify the malware? Well, anti-malware software allows you to run scans against the system so that you can hopefully identify it if there's an issue. A lot of times you can also look for what we call the top talkers or the systems that generate the most traffic on your network, and those are likely to be infected systems because malware tends to generate a decent amount of traffic. Last, don't forget about user education. Not only do you want to initially train users so infections are minimized, you also want them to be able to identify potential issues so that you can handle them as early as possible before damage is done. Firewalls are a device that acts as a traffic filter to protect an internal network from unauthorized access. The most basic firewall uses a list of rules called an access control list or an ACL to either deny or permit inbound and outbound traffic. There are several types of firewalls that you need to know about. First, we have network-based firewalls, which have a physical hardware appliance, which is either a dedicated piece of equipment or it could be built into a router, and it sits in between the internet and your internal LAN. They're only focused on traffic entering or exiting your network. And then we have host-based firewalls, which are software that's installed on a host and is focused on traffic specifically entering or exiting that machine. A really good example is the Windows Defender firewall that's installed by default on all Windows operating systems today and has been for a while. Linux has several options, but IP tables is a popular choice as well. One of the problems with traditional firewalls is that they're considered stateless inspection firewalls, and they don't look to see if the traffic is part of an existing connection. They just analyze each packet on its own and compare it against the access control list. Let's talk about some of the more advanced and newer features that you can get on firewalls now. Stateful inspection firewalls are a modern technology where the firewall can block these unsolicited packets if they aren't part of an existing connection. Some firewalls are application context aware and can operate all the way up to layer 7 of the OSI model to filter based on the application or service that originated the traffic. Next generation firewalls, or NGFWs, are capable of operating at many layers, including up to layer 7 of the OSI model, which makes them far superior to a traditional stateless firewall. Let's talk about the entire implementation process of a firewall. Location is key when implementing firewalls. The most common place that you'll start implementing a firewall is between the internet or the outside world and your internal network. Firewalls go in line with traffic, so that means all the traffic flows through them. That's an important concept to understand because you need a device that's powerful enough to handle all that traffic, or your network performance is going to start slowing down to the outside world. Some organizations will need a demilitarized zone, or a DMZ, which is also called a screen subnet. This is basically an intermediate area of the network that sits between the internet and your internal network to provide services like the web server that's accessible to the internet. You need a firewall to filter traffic between the internet and the DMZ and traffic going between the DMZ and your internal LAN. That means you need 2 firewalls. This kind of setup works on levels of trust based on network segmentation, where the internet is the least trusted, your DMZ is a little bit more trusted, and the internal network is the most trusted. We aren't going to really dive into it here because it's more of a security plus and beyond topic, but I'll also make the point that something called zero trust is a shift away from this traditional mindset where we don't assume trusted communications even on the inside of our network. Once your firewalls are connected into the network, you need to start creating access control lists, or ACLs, which are a list of rules that say which traffic is permitted and which traffic should be denied. These lists are processed from top to bottom, so keep that in mind because order does matter. You can filter based on source IP address, ports, and other items depending on how sophisticated your firewall is. Some firewalls have web filtering to block specific web access. Some have content filtering to block based on signatures or keywords, but all will have both IP filtering and port filtering capabilities. Many firewalls have what's called implicit deny rules, which means that anything not matching a rule on that access control list is going to be blocked. This rule might exist without you having to even add this kind of rule to the list, but it's best practice to create the rule, especially at the bottom of the list. For completeness, any deny rule that you actually configure on the list will be considered an explicit deny rule. Troubleshooting firewalls basically comes down to 2 major issues. The first is incorrect ACL settings. Did you forget about the implicit deny? Is there a rule permitting or denying that traffic that needs to be changed? The second item is misconfigured applications. Applications like your built-in software-based firewall on Windows might have a setting to block a certain service or type of traffic. That's pretty easy to fix. Just open up the firewall application and find the rule causing issues and fix it. Depending on the strategy of your security team, they may want to implement honeypots or honeynets, which means those systems might have more lenient rules associated with them. Honeypots are systems that are intentionally made to appear vulnerable as a decoy. By using honeypots, security teams can analyze attackers' behavior and see what they're up to. These systems might have open ports or juicy file names like password.txt to see what attackers are actually going to do, and we can improve our overall security. Honeynets are networks of honeypots with the same idea, and they intentionally appear vulnerable. Both honeypots and honeynets have to be on isolated areas of the network and separate VLANs, because if they're compromised, you don't want that to lead to the rest of your network being compromised. Be very careful if you implement a honeypot or a honeynet.